We interrupt your regularly scheduled broadcast to deliver some breaking news. Magnetism, waves, the frequency spectrum. What is it all about? Invisible forces are all around us, working in our lives in unexplainable ways. Here at the Procrastination Station, we plan to unearth this mystery, and it all starts with the waves.
Hope you have some goggles because we're about to crash into some waves. So as you can see, waves are a disturbance that propagates or travels through space from the place where it was created. Not to be confused the ones that you surf on. Now we have multiple types of waves. We have mechanical waves, which need a medium to travel through, which they can be either transverse or longitudinal. When it comes to transverse, the waves almost look like hills with valleys, whereas longitudinal waves look like compressing lines on each other. There's also electromagnetic waves made from electric and magnetic fields. They, however, do not need a medium to travel through. Now, with waves, we have both periods and frequencies. A period represents the time it takes for one complete event. This is often measured in seconds. We have a frequency, which is how often an event repeats itself. It's measured in hertz. And those two, they work inversely with each other. So when a period goes up, the frequency goes down, and vice versa. The formula is F equals 1 over T, or the frequency equals 1 over time. Here is the anatomy of the wave. Right here we have the transverse wave. It has the crest, which is the peak, the trough, which is the valley. We have our wavelength, which is from one crest to the other crest. And we have our amplitude, which is how high it goes from the starting point and how low it goes from the starting point. This gap right here. Also, here is the longitudinal wave. It has the wavelength across, the compression, and the rarefaction.
As you can see, in South Texas here, it is very hot. Actually, magnets! So, as you can see, the first question we need to ask when we discuss magnets is, what is a dipole? A dipole is a system with two magnetic poles, north and south, separated by a very small distance. Also, we must ask, what are these lines coming from these magnets? These are magnetic field lines, which is a visual tool used to show the direction of the magnetic force. As you can see, these lines usually travel from one end of the pole to the other, and only from one end to the other. North always goes to south, and south always goes to north. Next, we must discuss magnetic flux. Magnetic flux is the measure of the total amount of magnetic force that is passing through an object between the poles. To find magnetic flux, we use magnetic field, the area of the object it is passing through, and the angle of the magnetic field to the object. So, this could be going this way to the object, or it could be going this way to the object, or, as described here, it could go straight through. Next, we're going to discuss magnetic domains. This is a region where the magnetic fields of atoms are grouped together and aligned, all facing the same way. And this allows for an object to actually be a magnet. Next, we're going to talk about ferromagnetism. An object that is ferromagnetic has a high possibility of being magnetic. Not a magnet, though. This is only magnetic when there's a magnetic field applied to said object. But it can retain magnetism for a period of time, depending on the strength of the applied field. And finally, paramagnetism is an object that is very weakly attracted to magnetic fields and cannot retain magnetism at all. That is all.
Thank you, Lindley, for that rousing weather report. Now on to the electromagnetic spectrum. The electromagnetic spectrum is the full range of electromagnetic radiation, shown through frequency and wavelength. Some waves can be as big as buildings, while some are as small as an atom's nucleus. Within the electromagnetic spectrum is the visible spectrum, and this is the frequency of light that can be captured by the human eye. Beyond that, we have infrared and ultraviolet, which allow us to see heat waves and hidden residuals. Even further on are radio waves and gamma rays. We use many different types of machines to perceive wavelengths that we cannot otherwise see. This includes sonars, radios, thermal goggles, and ultrasound. The discovery of the electromagnetic spectrum began in the 1800s when William Herschel discovered infrared radiation using a prism. Now, 225 years later, we are still making such breakthroughs. This chart is an incredible tool for astronomers, allowing them to distinguish physical characteristics such as temperature and composition of unknown objects. That was it. That's all I got.
Run!
Better late than never. The procrastination station, delivering your news the day after it's due.